Hello. Basically, I choose a topic on widlar current source. It's basically a circuit designed to maintain a constant output current when we connect to any load. A current will be constant irrespective of the load resistance. It circuit contains two power BJTs and two resistors with a power supply VCC. For this particular simulation, we choose a VCC of 8 volts. BJTs have the beta value of 190, and BJTs it has a constant value of 0.7 for its BE value, and I reference we are maintaining at 100 microamperes. BJTs both were similar, so Q1 equal to Q2, and top our challenge is to design the circuit for 5 microamperes of output current. This is a particular way of calculating, equational way of calculating for RE and R1 values. Due to by Kirchhoff law at node X, we can write a Kirchhoff equation that will be comes out as I reference equal to IC1 plus IB1 plus IB2, and by if you consider the loop from one ground to other ground, we can bring out an equation like IBE1 equal to IBE2 plus RE into IE1 based on KVL equations. And we know that for BJTs, carrier current at any point equal to saturation current into e power times of V PE by VTH. Those equations were written for both the BJTs, and also we rearrange the equation in order to equate the remaining equations are both VBEs, and substituting these both equation in KVL equation that we divided earlier, we will get an equation of V threshold into ln of IC1 plus IC1 divided by IC2 equal to RE into IE2. And also we can rearranging the equation 1, we can bring out the equation equation 4, and substituting these equation 3 and 4 in 3, we can get an equation shown here. This equation is approximated to the shown equation. From this equation we know the R reference current reference and the IC2 values that we are desiring for. In this case we are desiring for 5 microamperes amperes of current, and I reference we chosen for 100 microamperes. And since we know each and every value in this equation, we can calculate the RE. And also if we know the RE, from the equation 2 we can calculate the RE1. RE1 can be calculated as current through this branch, that is I reference we know it, and voltage difference also we know. Since this VBE voltage is 0.7, here voltage difference will be 8 minus 0.7. With the voltage difference and knowing the current value through, you can find the R1. That's the solution to find RE and R1. Here RE is R2 here, and this is the simulation setup schematic that we have designed it. BJTs were chosen 2222 type of BJTs which have a beta value of 190. This is the simulation result we can show. This is the I reference current which came up as 100 microamperes, and the output desired value was stable at 5 microamperes. And the simulation steps followed as the circuit was designed, and we got a reference R1 value as 7.73 kilo when we calculated through the above equation that I described before, and RE, that is R2, I got around like 15.1 k ohms resistance I got it. So step initially we will sweep the R1 value. R1 value is swept from 73 to 74.16 kilo until we get the desired I reference current, and also RE value swept from 15.1 to 15.1 by 15 until we get the desired value of 5 microampere. That is the simulation steps that we need to perform in order to achieve a constant output current. This is the simulation of output plot of carrier current, output current with respect to load voltage, that is V1 here. V1 is varied from 1 volt to 14 volt, and we observed the minimal variation in the output current, which we can we can say that output current was designed to maintain a constant current irrespective of the voltage applied to it. Thank you.